get some discussion going related to agent-based models, and some reflection on the issue of model boundaries as well. So, can anyone here tell me what's an agent-based model? Okay, so persons are often natural agents because if we're characterizing a population, as we've been doing for many of the examples, it's at a person level that often decisions are made. The person who gets sick, the person who recovers, the person who dies, the person who seeks care, by going to hospital. And so a person is kind of a natural level of description. And tell me, does a system dynamics model or aggregate model of the sort that we've seen, does that characterize people as well? Behavior of people? Behavior of groups of people. Okay. So people get sick in that model. They move from susceptible to infected. Recover. Mm-hmm.
Individual-based models.
Yeah, that's correct. Yes, and we'll see that quite a bit in some hybrid models. It's a very exciting domain. The advantage of articulating at a so within a system dynamics model, within an aggregate model of we've seen, so it's more specifically aggregate, which is the most common way of describing it with system dynamics. We have a difference between that and how we do it at an agent-based level. Some of the differences are brought out in this slide here. So in a system dynamics aggregate characterization, we have the model organized according to the state that someone's in. So they're susceptible, they're infected, they're recovered. And for each of those categories, and each of those elements of organization, representing the state or the characteristics of a person, maybe these are age categories, maybe you have males up here and females down here, and so you distinguish by putting them in different stocks. We count individuals with different characteristics, right? Here we organize the population according to their characteristics, and for each of those stocks, we count the number of individuals with that characteristic, right? The characteristic might be so that it changes over time, like their infection status or age. It might be something that's more or less permanent, like their gender or ethnicity or something along those lines, right? System dynamics aggregate model characterizing things like that. Dividing up or organizing the population according to characteristics or attributes, and then counting the number that represent that attributes. How is it different for an agent-based model? Excuse me. How is it different for an agent-based model? What is the population in an agent-based model organized by? Agents. We divide it into a set of agents. We don't divide it up by attributes. We don't have different stocks for males and the count of males, count of females. Instead, we have agents. And there's some agents who are females, some agents that are males. Each agent keeps track of its own state, keeps track of its own characteristics, its own attributes, male, female, whether it's infected or not, what its age is, its ethnicity, what have you. These are all kept track of by that agent. So we have some important distinctions there. Another distinction is that within an agent-based model, we will often, as compared to an aggregate model, because that's the operative distinction, individual-based model and an aggregate model are often the two sort of key things to compare. System dynamics is a way of specifying a model's dynamics, or gives a way of specifying It's not inherently aggregate, although it just happens to be applied that way for many, many models. So in an individual-based model, like an agent-based model, we might also divide up things. Oh, I had a beautiful diagram, but it's somehow lost. So we can also have multi-scale models. What I mean by that is we might have agents here at the low level who are individuals, people, and then we might have them grouped into a neighborhood. And that neighborhood might itself be part of a city, which is composed of multiple neighborhoods. And the city might be an agent. And hang references to it if you want to be specific about it. These neighborhoods and neighborhoods contain references to these individuals. And the city, of course, might be in a region, etc. So we have a structure of the agent-based model where we have a kind of nesting of contexts that in some sense mirrors kind of the nesting we see in the world. We are in the context of the classrooms, in a building, in a university, etc. And those may be different agents. Often the agents are people at the most basic level, but we might have an agent associated with the city because there's city decision making. There's city-related dynamics associated with finances and operations and fleets of buses. And who here is new to Saskatoon? Okay, so there's also a thing called snow here, and there are fleets of vehicles that are graders, they're called, and they deploy in the winter. And they sweep away the snow and ice off the roads, and you'll get to see them and meet them too. Hopefully not too closely. So, the point is the city could be represented as an agent. A person could be an agent. You could have a neighborhood as an agent if there were dynamics associated with it, etc. You might have a city and a region or what have you. So. Here we have sort of aggregate models and agent-based models, and we have a different way of organizing them. It turns out great insights can be gained on both sides. And this course may be unique in the world, actually, for talking about the hybridization of these, and we'll be spending some time on that. One of the key points I want to communicate to you, that those lessons we learned in analyzing stock and flow models. Why is the stock going up? Under what conditions would it go up? Well, the inflow is greater than the outflow and so on. You could apply those to an agent-based model's dynamics as well. You could think of the people, okay, there are these people in the model, you could think of them conceptually as being associated with changes that represent inflows or outflows from the stock and reason about the dynamics of that. So the stock and flow perspective or lens will remain very useful. But here we're seeing a contrast in terms of describing like a population using an aggregate fashion or an agent-based fashion, a real difference in organization. We talked about one motivation, this issue of a multi-scale model that was left out of here. What other motivations might there be for an agent-based model or characterizing things at an individual level? Why? Why might we characterize things at an individual level? Rather than... Okay, history is a huge thing. History is huge. Let me ask this, folks. This is unfortunately not the perfect example to represent it, but ladies and gentlemen, let me ask this. Let me push you a little bit. So you folks, when you watched that first video, you actually built up a little agent-based model, right? Or you modified it, right? It was originally a susceptible, infective, and recovered model, right? What did you do to modify it? Change some parameters first, and then what did you do? Transition. Okay, how would we mirror that? If we want to have a similar characterize the sort of same system with that new transition here, how do we do it? Sorry? From recovered to susceptible. Good. Excellent. Excellent. So let me ask this. In the agent-based model, you have these agents who go through these stages, susceptible, infected, recovered, and back, right? Is it possible that a given agent might get infected more than once? Is that possible? Suppose we wanted to record how many times a given individual is infected. Could we do that in an agent-based model? Yeah, it turns out we could. Every time, we'll see how to do it in detail, but every time they go through that transition to infection, we could increment a counter. They have some counter that keeps track of the number of times they've been infected. We could, every time they go through that transition, we could increment that counter. So it goes 0 at first time, it goes to 1, 2, 3, etc. We could do that, right? We could keep track of how long it's been since the last time they were infected, etc. Could, okay, so I want to talk about this. Right. So again, the issue is aggregate in an aggregate model. How would you suppose in this aggregate model we had that return flow? Could we keep track of how many times the population has been infected? Each person in the population has been infected. If so, how do we do it? Okay.
So one state would be never infected and susceptible.
Okay.
They would be infected once and susceptible.
They have been infected once. You could have a whole copy of this. So recovered, the flow from recovered would now no longer go back to susceptible. It would go to susceptible and infected once before. And then infective and infected previously once before. Recovered and infected once before. And then the flow from recovered once before for waning immunity would go back to susceptible twice infected before. So you could actually sort of separate out, but it would get awkward as the number of things you want to record. If you want to have recorded to 100 times, you need 100 copies of this. One copy for each number of times that you've done, right? So, but you could actually try to do it. Let me ask this. If you just kept it, so you had the recovered going back to susceptible here, so you had a flow back to susceptible. Well, let me, right. Could we tell by looking at the people in susceptible which of them had been recovered before, had been infected before? No, we can't really ask it. But it just went back to susceptible because there's no way of knowing. Their state is entirely summarized by being susceptible. So this is sort of a Markovian assumption for whom that's a meaningful notion. In other words, the fact that they're in this stock totally summarizes all the information you need to know about that person. In this case, all we need to know is they're susceptible. So we can't really ask the question, okay, the person who's here, were they here before and they got infected, or is it a different set of, is it only people who have never gotten infected here? We can't really ask those sort of questions. Or what fraction of the susceptible people here have been infected before? We don't have a direct way to sort of ask that question. We might be able to guess from statistics, broad statistics, how many people have come back, but keeping track of actual trajectories of individuals is not feasible. Okay. So history information.